So good morning to all. So actually now we are in the class of MT8701 Robotics and Machine Vision System. Okay. We all know that today the world is full of about robotics, and we'll be managing about machine vision system. So by learning this subject, so what you can learn about now, so you can learn about what are all the basics of robots which are available over on it, and what are all the programming, and what about the machine vision applications in robots. Okay, so that will be, so apart from that, so we'll have a different course outcomes for the robotics and machine vision systems. So we'll have, so based on the each and every unit, so we can able to define what is the outcome from the each unit. Okay, so from the first unit, so the what you are all able to do it now, you can able to express the what are all the basic concepts, what are all the laws, what about the components, and what are all the parameters, so which are available, so that you can able to give the content. And the next thing you can able to know, you can able to define, or you can able to explain what are the types of grippers and its functions. And from the third unit, so you can able to evaluate the kinematic calculations, and you can able to apply Lagrangian Newton-Euler formulations, so which can be which are used to analyze dynamic characteristics of robots. And similarly, it can be able to describe the various programming techniques which is used in industrial robots also. And by the fifth unit, we can able to define what are all the basis of machine vision fundamentals over it. So this is the syllabus of the robotics and machine vision systems. The first unit which says about the basics of robotics. Okay, and we can able to define what are all the robot end effectors, robot mechanics, and what about the robot programming, and how we can able to define the machine vision fundamentals. Okay, so the textbook you can refer the MP Grover, so that I also already send you, B Medalite. So you can, and the reference book also, which is given the introduction to robotics by John G. Gregg, theory of applied robotics by Jazar, and R.C. Gonzalez by K.S. Fu and G.S. Lee, and similarly, robotics, sensing, vision, and intelligence by K.S. Fu, Gonzalez, and Lee, and robotics, technology, and flexible automations by Satya Ranjan Debra. Okay, so let me start with the first unit. So first unit already said you that which says completely about the basics of robotics. Okay, so in this thing we are going to know what are all the basic components of robot, and what are all the laws of robotics, and what about the classifications of robot, and how we'll have a workspace, accuracy, resolutions, and repeatability of robot. And apart from that, we can able to define the power transmission system, and what are all the rotary to rotary motions, rotary to linear motions, and what are all the harmonic drives, gear systems, belt drives, which are available, so that we can able to discuss in the basics of robotics. Okay, so first we have to define robot. So can anyone define what is a robot? Okay, so robot which is reprogrammable, so that we can able to do some modifications in the program. Okay, so that is why we are defining reprogrammable. And the next one, it is a multifunctional manipulator which is designed to move material, parts, tools, or special devices through variable programmed motions for the performance of variety of tasks. This is the actual definition of robot. So what we can say it as a robot? So the robot, we all know that it can able to do all the tasks which has been assigned. So how the task has been done? So we have to do some modifications. Okay. So in the assigning of tasks, the thing is to be that we can able to design a robot in order to pick up some materials, or we can able to have a move materials, parts, tools. Okay, so similar kind of activities which can be done by the robots, and all the tasks which has been carried out with the help of program. And what we can say it of that program will also, it is also to be the reprogrammable one. Okay, so that is how we are defining a robot. So what is the actual definition of robot? A robot is a reprogrammable multifunctional manipulator designed to move material, parts, tools, or special devices through variable programmed motions for the performance of a variety of tasks. Okay, good. So this is the definition. The next thing what you have to see of why we are using robots. Why we are using robots. So we all know that as of now, pandemic situations, so the robots which can be used replacement of a medical oriented. Okay. So we have a consistent performance. So in repetitive, this boring tasks, machine loading or inspections. Okay. And similarly, we can go for a we can go for hazardous or uncomfortable environments. Okay. So we can go for spray painting, arc welding, grinding, deep sea diving, radioactive materials handling. So all these things which has been worked over on it. So we'll have a multiple tasks, and we'll have a very difficult task to carry out. So all this which is the task which will be feel very difficult for the case of an human being. So that all these things can be replaced with the help of a robots. So the first thing, so in order to do all these tasks, we can use a robot, so we can have a cost reduction as well as we'll have an increased productivity. Okay. So when we are saying about a robot, so we all know that it can able to work up to 10 times faster than the people in repetitive low tasks. Just so we are going for welding or drilling or rebuilding, whatever it may be. So the work will get more faster. Okay. And the same time, the robots will work at the same rate as a person. What a human being is done, so the same will be carried out with the help of robot. But cost wise, so 50% as much as a person per hour. Okay, so that is a difficult one. And the third thing, so we all know that the robot won't take a rest. So it can able to work 24 hours per day, so that we doesn't have it doesn't take any breaks or sick leave. Okay. So these are all the things which we'll be using for the robots around it. So this is the sample thing. So it can able to work also similar kind of robots. So this robots which is used to do all the tasks what we are being assigned, and we can able to have a reprogrammable in order to construct the robots. Okay. So this is the thing which is used to pick and place. So or it can able to handle the tools. So which is used for over here. So when we are going for an so we are defined what is a robot, what is the use of robot, everything. So before that, we have to know what are all the histories or what are all the advancements in robots behind over on it. Okay. So the first generation, that is the first generation. So in which in the year of 1960, so we have a repeating non-servo or pick and place or point to point. So this type of all this, there is 80% of all these robots has been generated in the year of 1960. That is the first generation which is available over on it. Okay. Next generation in the year of 1980. So we have an addition of sensing devices, and we'll have a path control capabilities. So in addition with the first generation, so we'll be using a sensors, and we'll have a path control. So you all know that, right? So that will be carried out in the year of 1980. So that was the second generation evolution of robots. And the third thing, we'll have a third generations. So we'll have online computations and control, and we'll have artificial vision and active force or torque interaction with the environment in the year 1992. Okay. And apart from that, artificial visions and the torque or interactions. So finally, in the year of 2000, actually, four generations, true android or an artificial biological robot or a super humanoid capable of its own clones. Okay, that has been generated in the year of 2000. Okay, so now we all know that we are in the advancement in the year 2022, that the 2021, sorry. In the year, we'll have about an so more advancement in all the fields of medicals, industrials, hospitals, sorry, medicals or industrials, okay, and agriculture, okay. So more evaluations and generations has been, we'll have a more advancement in the case of an robotics, okay. So what are all the advantages of using robots? The first thing, flexibility. So it is essential for automations of batch reductions. Okay, so we'll have a more flexibility when we are using a robot. Similarly, it can able to reduce change over time and cost needed for mixed products on high volume lines. Okay, and similarly, we can able to have a better quality. And finally, we'll have a consistency in production rate and quality. And we'll have an increased productivity rate and quality. So this will reduce lead time and capital cost. We'll have an increased morale of the workers and a reduction in overall manufacturing cost or price of unit. So these are all the advantages of using our robots. Okay, so we'll have a flexibility, reduce change over time, we'll have a better quality, we'll have a consistency in production rate and increased productivity rate. So it can reduce the cost, increased morale of the workers, and reduction in overall manufacturing cost or price per unit. So top 10 industrial robot manufacturers. So you all know that for all the robotics manufacturers, so we'll have a ABB, there is Asia Brown Boveri. So he's the first thing. So he is the leading supplier of industrial robots and robot softwares. And similarly, ABB is available in Switzerland. And second one, Yaskawa. So Yaskawa, he is in Japan. So Japan is manufactures so that there is we'll have a servers, motion controllers, AC motor, drive switches, and then industrial robots. And in Germany, KUKA, that is Keller and Knapp and Ogilvy. The company manufactures industrial robots and solutions for factory automations. And we'll have the next one, Yamanakshi Prefecture. So he is headquartered in Japan, the company which provides automation products and services as robotics and wireless systems. And Kawasaki, Japan, it is a Japanese multinational corporation based in Tokyo, Japan. The company, so it is a manufacturer of motorcycles, heavy equipment, aerospace, and defense equipment, rolling stocks and ships. And similarly, Epson, it is a Japanese electronics company. It is a leading manufacturer of computer printers, information and imaging related equipment. Okay, and Stobeli, so it is a Swiss mechatronics company. It is situated in Switzerland. So they are manufacturing textile machinery, connectors, and robotics products. And in Nashi, it is a Japanese corporation. The company manufactures industrial robots, machining tools and systems and machine components. And we'll have a Como, so it is a leading company in the industrial automation field. So it is a subsidiary of automaker Flat Chrysler Automobiles. And Omron Adapt, so it is a multinational corporation with headquarters and for industrial automations and robotics, including software and mission guidance over on it. What are all the basic components of robots? So basic components, we can say that we'll have an input device, or we can be named as an teachment, and we'll have a computer controller, we'll have a mechanical arm, we'll have a program network and end of tooling and power supply. So this is the blocks which has been interconnected for the robots. So the major components what we'll be requiring: controller, robot arm or manipulator, end effector, drive mechanism, sensors and transducers. Okay, so these are all the basic components. What are basic components? Controller, robot arm or manipulator, end effector, drive mechanism, sensors and transducers. And what are all the basic components of robots? So we'll have a there is six. There is it is to be the 6 revolute joint robot. It is 6 are robot over here, and we all know that for supply we'll have a motion power unit and we'll have a control unit, and we'll have a shoulder, elbows, arms, wrist, manipulators. So these are all the basic components which is behind in the case of an robot. Okay. So in this sense, so the remaining thing that we can see in the next class. Okay.